So my next story is a quick one then, Tom.
Sure.
It comes by way of the Chandra X-Ray Observatory on Twitter.
Chandra.
They write on Twitter, this new image of the Crab Nebula combines X-ray light from Chandra, optical light from NASA Hubble, and infrared light from NASA Spitzer. More about this intriguing supernova remnant and the powerful pulsar at its core in this here article, which I printed out.
So we got some new stuff about the Crab Nebula.
Yeah, you know, I just wanted to highlight this because I saw this and I was like, wow, this is freaking cool. K-Boy's got the tweet probably up on the stream, so you guys can see this this little GIF that they've got put together. The X-ray light data is kind of the white light that you see there. The Hubble data light is kind of the more purplish, bluish color. And then the infrared is kind of this pink, almost background light that you see there.
And it goes in between each of those?
Yeah,
okay.
And it's kind of varying between all three of those guys there. And I just thought this was fascinating because if you compare this to the normal image of the Crab Nebula that you think of, right? If you go to Wikipedia and just
Google it,
look up, the Crab Nebula, you would see this other kind of image, and I sent you a picture of that, Kyle. I don't know if you have that up and loaded up into the into the OBS there. Maybe not. If not, that's okay. You guys can just really quick do a Google search of the Crab Nebula, and you won't see anything like what
that looks like that.
Yeah, like what we're seeing in the tweet here.
Good to go. We got it up.
Awesome. So in the article, they just write, next year marks the 20th anniversary of NASA's Chandra X-Ray Observatory launch into space. That's crazy to me because I remember 20 years ago when that was a thing, and I was like, wow, that's very fascinating. 20 years goes by too fucking quick, Tom.
Yes, it is.
Okay. They go on to say, in the case of the crab, observers in several countries reported the appearance of a new star in 1054 AD.
Which is a segment of the sky?
No, that's a year.
A year.
Long time ago.
Okay.
Yes, it's about
I wasn't following you there for a second.
Almost 1,000 years ago in the direction of the constellation Taurus. So that's how we know that this was a supernova.
Okay.
Right? This was a star exploding in the night sky, is because people in the year 1054 were like, holy fucking shit.
There's some crazy stuff in the sky. Right?
What's going on? That's crazy. So now this latest image of the crab is a composite with X-rays from Chandra, that's the blue and white, NASA's Hubble Space Telescope, that's the purple, NASA's Spitzer Space Telescope, that's the pink. The extent of the X-ray image is smaller than the others because extremely energetic electrons emitting X-rays radiate away their energy more quickly than the lower energy electrons emitting optical and infrared light. And so I just wanted to put this out there to showcase that when you look in different wave bands of light, you can see different things. Yeah. You know what I'm saying?
Most definitely, yeah.
So what we're seeing here is like a really nice display of the pulsar, or the kind of really fastly spinning neutron star that is the remnant of what was once, a massive star that exploded. We see that in this composite image of wavelengths of light that our eyes are not really sensitive to. But when you look at the kind of normal image of the Crab Nebula in Hubble's grandeur of optical light and some other ultraviolet and infrared wave bands, we see kind of just the explosion remnants. So we're seeing two different sides of the same physical phenomenon here, and this just caught my eye. I just thought this was really cool. So I don't know if you've seen it, but
yes, I have.
Yeah.
Yeah. So when you're looking at stuff in space, what I learned by taking a lot of space classes was that when you see an image, a lot of the times they are looking in different wavelengths of light, and a lot of times it's not what you can just see with your naked eye. But that's really where the cool features come from. Like if you do look in the X-ray or the gamma ray or different wavelengths, you see features that would be invisible or otherwise unseen.
That's exactly true.
Cool stuff.
Yeah.